we're going to start off by using our imagination a little bit. I want you to imagine with me that you are in an airport. You dressed up for the occasion. You wore your best pair of sweatpants. You brought a neck pillow, and you're already wearing it. And I mean, it looks ridiculous, but you're prepared, and that's good. Then you waited in this ridiculously long security line. You answered all the pointless questions, like, did you pack your own bags? Yeah, of course you did. You did everything you were told to do. You threw away your water because it's dangerous. You took your computer out because, as we all know, the one thing X-rays cannot penetrate is nylon. And you even let them see you naked and receive a full body dose of radiation and got just like a few steps closer to developing cancer. Then you went through a never-ending duty-free shop, and eventually you got through that and saw, wow, your gate is really far away. At this point, you're running a bit late. You're worried you're going to miss your flight. But you see this kid, and she's riding her dad's luggage, and you remember, you prepared for this. So you get on top of your suitcase, and you zoom across the airport. But you get there, and it's delayed. Why is it delayed? It's not raining, it's not snowing, the plane is right there. Well, they won't always tell you this, but it's probably because the plane is broken. It's a good thing you've got your sweatpants and your neck pillow, because you might be waiting for a while. So settle in. We're going to take a look at what's happening behind the scenes. So to start with, the pilots or crew or someone is going to report a possible AOG. Aviation is full of initialisms and acronyms, but today we're only going to learn one, and that's AOG. That means aircraft on ground, which is the aviation term for a broken plane. So this AOG will be reported to the Maintenance Control Center. This is the maintenance controller. He's blue because this and all of the upcoming behind-the-scenes photos are real. These are not stock photos. And this is a real maintenance controller. He's not really blue, but we do need to respect his privacy, so today he's blue. Now this doesn't look like much, but there's a lot going on in this photo. So you'll notice the three screens. On the left-hand side, there's a flight schedule. All the planes are represented there. Every line is a plane, and every little block is a flight. In the middle, there's an internal maintenance suite with technical information there. And then on the right-hand side, there's a work order system. Behind him, on the wall, is a huge table of upcoming and current flights that he's coordinating with other maintenance controllers. In front of him, where he's sitting, there's a notepad with more tables of flights that he's dealing with personally. To his side, there's a phone that has dozens of people on speed dial, because he needs to be very fast reaching out to people. And nearby, he has other communication equipment, like radios. He also has 3 mobile phones in front of him. Why does he have so many phones? Because he needs to simultaneously coordinate between multiple parties. So why does he need all of this? The controller is the nerve center of AOGs. He receives a call from a pilot, from crew members, from inspectors, from maintenance, and he has to act as the help desk. He's a very experienced mechanic, and he has to fix planes remotely using tools and technology from the previous century. So controllers have to deal with a lot. And because of that, they typically look like this. So we're going to walk through what he's dealing with to diagnose this issue. To start out, he needs to find a mechanic to work on this. Airports can be huge, and it can be difficult to locate the correct mechanic. So ideally, the mechanic is physically near the AOG, but additionally, the mechanic has to be available, obviously, have the appropriate skills, be licensed to work on that specific plane, be contracted to bill for work on that specific plane. It involves a lot of calling, emailing, and texting to figure this out. That's going to take a lot of time. Today, we're lucky, though, because our controller found a mechanic very quickly. This mechanic is named Bob, or at least he's wearing Bob's shirt. OK, so at this point, some time has passed, and you're trying to get comfy. Eventually, Bob is going to get to the plane. Now, our controller doesn't know this because Bob does not have GPS, something we're working on. So the controller is constantly going to be pinging the mechanics, like, are you there yet? Are you there yet? And using phone, text, email, any sort of communication available. This is taking a bunch of time. The mechanic will get there and probably start consulting some manuals that we'll have to find, running some diagnostics, and will eventually report, in this case, that it needs a specific tool to fix this issue. So this is going to obviously take time. At this point, people are just like sprawled out in front of the gate. It's ridiculous. So our controller is going to search his systems and tell the mechanic that luckily they do have that required tool. So Bob is then going to go have to find it. But there are a lot of places to look. Fortunately, in this case, it was in the box labeled AOG. He probably should have started with that one, but it's OK. It did take more time than necessary, but it's OK. You're really trying not to use that neck pillow at this point. It's been a long time. So Bob might fix that issue, but unfortunately, maybe another one was surfaced. He'll go to investigate. Maybe he'll need to call for backup and have more people there to figure it out. And let's say this time there's a broken part needed. So they're going to search for this part instead of for a tool, not even in the SOS parts section, unfortunately. Obviously, that took a lot of time. So what do they do in this situation? They're going to have to ship it, sometimes on another plane, and that's going to take time for all the reasons that you think, plus you are not the only one who has to deal with security. Maintenance has to deal with this too. So all the parts have to go through security as well. All the tools, everything. So this will eventually arrive, the mechanics will install it, and then they're going to head home. But you're still going to be at the gate. Because the plane is not leaving yet. It still has to be inspected. More paperwork still has to be filled out. More stuff has to happen before it can return to service. At this point, you're thinking, a neck pillow is not even close to enough. You should have had a whole head pillow. This is the simplified version of events. The real version has more people, more roles, more coordination, more paperwork, more things that can go wrong, and more things that can take time. But this is not a talk about queuing theory or security theater or hostile architecture or your weird pillows. This is a talk about unscheduled maintenance problems in aviation. OK, so I'm Dom. I'm now the tech lead at Beacon, where we are trying to help people fix airplanes. And this is a talk about how we are using Clojure to do that. Beacon is a project from Embraer X, which is a subsidiary of Embraer. So let's start at the top. Embraer is the third largest producer of commercial aircraft in the world. It was founded and is headquartered in Brazil. That occurred in 1969, about 50 years ago. We actually just had the 50-year anniversary celebration. In that time, over 8,000 aircraft have been delivered, and there's now about 18,000 employees. So now we can talk about Embraer X. Embraer X is a subsidiary of Embraer, and it is dedicated to the development of disruptive business to build the future of urban air mobility. So currently there are 3 public projects in Embraer X. There's the eVTOL, which is the electric vertical takeoff and landing vehicle. This is not like a car. You're probably not going to buy one of these, but it will be available to take people to airports and other nearby cities, and this is actively in development. There's also Flight Plan 2030, which is, if you imagine the urban landscape like the urban skies like roads, you need a way to govern this and keep it safe for the eVTOLs, helicopters, small planes, drones, everything flying together. That's what this is. And then the third project, in my opinion, the best, is Beacon. So the Beacon platform, load. The Beacon platform is designed to connect and synchronize industry resources, the aftermarket supply chain, and aviation services professionals in a more agile and efficient way to keep aircraft flying. Our goal is to fix all the inefficiencies in unscheduled maintenance. So currently, Beacon connects aircraft operators, maintenance providers, and aircraft mechanics via web and mobile apps. Okay, you get the picture. So let's talk about Beacon's architecture. Our API server is Clojure, no surprise here. We use Postgres as our primary data store. We have a mobile app written in React Native and 2 web apps written in React. All of that is using JavaScript, not ClojureScript. There's also they all talk to one GraphQL Clojure server. So pretty simple. Also, Firebase is used for authentication, chat, and cloud functions, so a bit less simple. So I was responsible for building the Beacon technical team, and many of them are here, so come say hi if you see this shirt. So at this point, I've interviewed a lot of Clojure and JavaScript developers, and there are 2 questions which are super common. From JavaScript devs, why are you using Clojure instead of JavaScript Node? And from Clojure devs, why aren't you using ClojureScript? This is very predictable. I don't know. I also don't know why all these WNBA players are shrugging, but I saw them on Jiffy, and it just seemed right. So the Beacon MVP was developed by an agency. After the MVP was developed, it became clear that Embraer X needed to build an internal engineering team. That's where I came in. I was brought in to be the tech lead of that and to build that internal team and build the product from minimally viable to fully fledged. So I did not make the initial technology decisions on this project, and I can't really speak to those, but I can speak to our experience with them after taking over and how they're working out. So let's look at the MVP in terms of a few metrics. So we have about 6,000 lines of Clojure, not that much. We have about 66,000 lines of JavaScript, so not even close, more than an order of magnitude more. Now, there are obviously a lot of things at play here. For example, we have only one API, but we have multiple API clients, and they're not sharing code. So we're working on that a bit, improving that. Also, JavaScript is just more verbose, but it's still kind of striking. We also received 14 repos. One of them, the API, is Clojure. 8 of them are JavaScript. The rest of them are related to infrastructure, testing, and documentation. So this introduced a lot of incidental complexity, and we've since consolidated to 4 repos. In terms of reviewing the JavaScript repos and the Clojure repo, we found that there were 4 unique committers on the Clojure API and 18 unique contributors on the JavaScript side. This is striking, but at least it's not an order of magnitude more JavaScript engineers as there are lines of code. It is kind of interesting, though, because what this means is that the Clojure developers were writing much more code, or many more lines of code per person, which is not what I would expect given the language. So this is a visualization of commits to the Beacon MVP over time using a tool called Gorse. So in this 1 second equals 10 days. The days that don't have any commits are elided. So the turquoise dots are JavaScript files, and the purple dots are Clojure files. There's a legend on the left-hand side. Branching is based on directories. At this point, you can see there's more SQL and XML files than there are Clojure files, right? And obviously, there's an order of magnitude more JavaScript files than the next highest. Something very dramatic just happened there. I'm not sure what. Clearly, by any of those metrics, Clojure was a small part of the MVP. However, it was responsible for virtually all of the backend logic, right? So by importance, it's a big part. It's kind of striking how much can be done in Clojure with so few lines, especially when you compare this to JavaScript or even SQL in this code base. So we're at a Clojure conference, so let's talk about some of the pros and cons there. So you probably know lots of Clojure ones, right? It's on the JVM, we have this really strong foundation to build on. It's functional and very succinct, so more lines of code means more bugs. Less lines, less bugs. Immutable, mutation means more bugs, right? Very data-oriented. Most server-side work is basically I/O with like data transformation between the I and the O, and Clojure is great for this. And it's Lisp, so the syntax essentially doesn't change, and this is a huge blessing. And we have macros, so we don't have to, like, a lot of languages have to rely on preprocessors to do things that we can just do in the language. And we have a REPL, a really incredible REPL, not what most people think of as a REPL, which makes coding very, very interactive. And now we have specs, so we have this sort of like flexible, dynamic, useful validations, right? We have test check, which isn't, we don't use generative testing much, but it's super useful and super powerful. And obviously, the most important one is that it's just fun, right? But you know all this stuff. So the interesting thing to talk about here is JavaScript. But the thing is, I really tried to prepare this part, and anyway, so thank you very much. I'm kidding. OK, so the ecosystem, obviously, it's huge. It absolutely dwarfs anything we can even imagine. And there are a bunch of benefits to that and a bunch of drawbacks. So in JavaScript, we have a lot more noise. Obviously, we have a lot more noise at an absolute level, given the size, but it does seem to be more noise at a relative level, speaking completely subjectively. This was, I think, most evident in the hiring. Finding JavaScript developers to interview is very easy. Finding experienced JavaScript developers to interview is surprisingly challenging. This doesn't mean hiring for Clojure is easy. It's still a challenge, but it's been far less challenging. Now, it's entirely possible that this is just my bias. I'm connected to this community much more. You're my people, right? So maybe hiring Clojure is just easier at this small stage. But anecdotally, it's been far easier to find experienced and thoughtful Clojure developers. Clojure is also much more opinionated. Most of those opinions, I think, are quite good, and this is useful. In JavaScript, it's very unopinionated, so you have to bring a lot more of your own opinions and enforce those. Likewise, one opinion is mutability. So JavaScript, there's immutable.js, there's good immutable solutions out there, but you have to bring those yourself. It's not by default. Same with sort of paradigms, right? JavaScript can be used very functionally, but you have to make those decisions yourself and do that. Now, this is kind of an interesting one. Clojure very much eschews types, and I don't really have strong opinions about typed and untyped languages. I think there are trade-offs, and it's going to depend on the person and the project. And even though both of these are very dynamic languages, the JavaScript side has a much better story around gradual typing, if that's your thing. We have Flow, TypeScript, even ReasonML. There's quite a good story out there if you want to gradually type your code base if you're using JavaScript. Also, Clojure is a Lisp, which is great, but that also has costs. So everyone has their own preferred way of writing Clojure and their own preferred way of formatting Clojure. JavaScript has basically standardized around ESLint and Prettier for linting and formatting with a few common configurations. It's not 100% standard like Go, but it's much more standardized than Clojure. And if you're someone like me who wants to be able to determine who wrote a line of code by looking at git blame and not by just reading the code and knowing who wrote it, this is nice, right? We also talked about Clojure's REPL. This is phenomenal. It's really hard to imagine a more interactive, enjoyable, and productive way of coding. But there are also drawbacks associated with that because it makes developing new features very easy. It also makes it very easy to neglect testing. And obviously, there are certain ways you can obviously work around this. You can write tests. But the ecosystem around testing is much more robust on the JavaScript side. I think probably because the development workflow is worse. But outcome of that is that you probably end up with much better regression tests over time. OK, so regarding GraphQL, so we're using GraphQL. So to get the most out of it, you need to use some libraries. The most popular GraphQL client and server libraries are Apollo, and they're all written in JavaScript or TypeScript. Licinia, which is the most popular GraphQL Clojure library, is great, really great. I was actually using GraphQL Java with via Clojure before Licinia was released, and I'm very happy Licinia exists, believe me. However, it's not nearly as feature complete or battle tested as Apollo, just due to the size of the community like we're talking about. So we'll talk a bit more about this later, but the ecosystem around GraphQL is very focused on JavaScript, even on the back end. So this is kind of annoying. We can't rely on as much tooling that we should, or that we would be able to if we had a backend in JavaScript. Okay, last, the big one is code sharing and sort of knowledge sharing, right? So this is not specific to Clojure or JavaScript. If we were using Clojure and ClojureScript or just JavaScript on both sides, we would have this code sharing ability and knowledge sharing and have people be able to sort of move between code bases and understand the system more easily. Obviously, as you scale, this becomes less important. You get people more narrowly focused, more specialized, but as a small team, being able to share code and logic and knowledge is useful, right? Okay, so from a technical perspective, our architecture is very simple, or hopefully will be soon. We're working on that. Except one thing, which I just was talking about briefly, which is GraphQL, which is a very important part of this. So part of me does not want to talk about GraphQL here, because I've kind of fallen into the GraphQL Clojure guy role. I actually realized that every one of my Clojure conference talks has been in some way about GraphQL, and I made the GraphQL channel in Clojurians when I realized it didn't exist way back then. But we are going to talk about it just a little bit because it's actually very important for what we're doing. It allows us to support 3 drastically different kinds of clients using a single API. We don't need to build specific things for each kind of client. They can just use the same API to function as they need to. Also, related to the code sharing thing, GraphQL kind of makes this less important because we're able to move more of the logic into the API, and therefore we don't have to duplicate sort of logic in front ends and back ends. Okay, so brief tour of GraphQL. Okay, so first, GraphQL is not a programming language. It is an API language. It is not capable of arbitrary execution. So like you can have a GraphQL API, or you can have a REST API, as an example. I mean, you can't actually have a REST API because no one agrees on what REST is, and even if they did, you would have to do something different because REST doesn't actually work for graphic user interfaces, but I digress. Anyway, you can actually have a GraphQL API because it is a specification. So there's a formal spec. All GraphQL compliant servers behave approximately the same way. So GraphQL does not mandate any particular programming language or paradigms, JavaScript, Clojure, whatever. No mandate around storage backends. We can use Postgres or Datomic or the file system or whatever. It doesn't matter. Just an API language. Please do not let me hear you say, why should I use GraphQL instead of Datomic or Neo4j or something? That doesn't make any sense. It's not a database. Don't say that. It's very badly named. Okay. So the spec says that GraphQL has 5 design principles. So it's hierarchical. Most product development today involves the creation and manipulation of view hierarchies, and GraphQL mimics this. It essentially allows your queries to be shaped hierarchically, and then your data is returned in that same hierarchical structure, which is a very natural way for clients to describe data requirements. It's also product-centric. The spec says GraphQL is unapologetically driven by the requirements of views and the front-end engineers that write them. GraphQL starts with their way of thinking and requirements and builds the language and runtime necessary to enable that. So anyone trying to sell you on GraphQL being the best for everything is either deceiving you or deceiving themselves. GraphQL makes a lot of things on the back end, like caching, right? More difficult. However, it is very good for UI clients. In essence, it allows you to take a lot of the inherent complexity and move it from the client to the server. And this is almost always a very good trade-off to make for products. Another One of the 5 points is strong typing. So every GraphQL server defines an application-specific type system. Don't worry, it's a good kind of type system. We'll talk about this more in a moment. Just don't, calm down. So client-specified queries, through the type system, a GraphQL server is able to publish the capabilities that its clients are allowed to consume, and then clients are responsible for specifying what they want to consume and what they need at a field level granularity. So clients receive exactly what they need and no more and no less. The last one is introspection. So GraphQL is introspective. A GraphQL server type system must be queryable by the GraphQL language itself. So we're not really going to talk much about this, but the thing to take away from this is that the GraphQL ecosystem of tools is phenomenal and way beyond anything else out there, and it's enabled due to this introspection. So quick example, let's assume that a server has defined a schema that has a root field called user. It takes an ID that returns a user object, and there's a field called handle in that, and that's a string. You might have a query like this. It's going to return something like this, which you'll see corresponds to the things we talked about, hierarchical, product-centric, client-specified queries, and strongly typed. So strongly typed. These are the good kind of types. It's not like Java. So a type in GraphQL is more like a Clojure record or a datomic entity map. It's just a map with specific keys and specific values. And just more generally, sort of on this topic, using types or specifications or validations or assertions or whatever, right? Whatever you want to call your method of improving correctness is the most important at boundaries, right? So if your code can make assumptions, then it can be smaller and easier to reason about. But to safely make assumptions, you need somewhere that enforces those assumptions. So the API is a big, important system boundary, and GraphQL acts as the enforcer of assumptions at that boundary, which means the code that you write in your application can be much smaller because you don't have to deal with any of that internally. So GraphQL schemas can have 3 types of operations: queries, mutations, and subscriptions, which roughly correspond to read, write, and listen. Usually when we talk about GraphQL, we mostly talk about queries and mutations. These are both stateless operations. A client sends a request, gets a response, that's the end. You can scale queries and mutations pretty easily just by adding more servers. However, subscriptions, by contrast, are stateful. They require maintaining a GraphQL document, variables, other context over the lifetime of the subscription. They also require coordination to ensure that events are propagated to clients regardless of where the event originates or which server the client is connected to. And then you also need to think about how you're going to deal with like drop messages and things like that. So supporting subscriptions is a significant architectural change for any GraphQL API. And they require a lot of complexity, but the spec is very, very unopinionated about this. It says subscriptions are delivery agnostic. I won't read this whole thing to you, but it basically says you're on your own. We're not going to deal with like any details here. You can use WebSockets, you can use whatever, we don't care. We're not going to talk about how to reconnect. We're not going to talk about like handshakes. We're not going to talk about buffering. We're not going to talk about anything that's not part of the spec. That's your problem. That's essentially what it says. So if the spec says like nothing about how to use subscriptions, how do you actually use subscriptions? So we talked about Apollo and Licinia, and that's how. Apollo is probably the most popular GraphQL client and GraphQL server, but it is implemented in JavaScript. There's a very large ecosystem of Apollo libraries and tools. Apollo has a library called Subscriptions Transport WS, and that works, which WebSockets, obviously, and that works with its client and server. So it basically makes all the decisions for you to make subscriptions work over WebSockets, assuming you are OK with JavaScript and OK with Apollo and OK with WebSockets. Then subscriptions are basically plug and play. So we're using Apollo on our clients, actually, but our server is Clojure, so Apollo is not an option there. However, we do use Licinia and Licinia Pedestal, and the Licinia Pedestal library ships with interceptors that implement the same WebSocket protocol that Apollo specified for their things. So it's not as battle-tested as Apollo Server, but it mostly just works. So as an example, mechanics are out there working on planes, and they need to be updated if any changes, right? So we have quite a few types of subscriptions, but let's just say this is for subscribing to a particular AOG. The AOG subscription takes an ID, and then it's going to publish or push updates to the client that requests this whenever the AOG changes, and it'll just send over the action and the case fields of that AOG. This is very important for us, right? Because Beacon works by being real time. Like, we need instant communication. So subscriptions are vital for our functionality. So our backend implementation of this is based on core async. We essentially publish events to a channel, and then those active subscriptions are connected via WebSockets. So within a single instance of the API server, an async channel is a sufficient pub/sub mechanism. However, when you are in a clustered API environment, you need an external pub/sub system. So currently, we use something for this called NATS, but that's not really, like anything would essentially work based on your criteria. So you could use Redis, you could use Postgres, listen and notify, you could use SNS, whatever. The exact implementation that is right for any particular subscriptions use case is case dependent. For example, we are able to send every message to every server and then let individual servers filter messages that are required for their connected clients. But if you had hundreds of thousands of concurrent connections, this would not be feasible, right? So you have to deal with your specific needs. The important thing is that subscriptions make things more complicated because you need to coordinate servers around a distributed transient state, right? Okay, so to make this transition slightly less jarring, our subscriptions are not the only thing that is distributed. Our team is also distributed. We work remotely. We have team members across 5 time zones in Brazil and in the US, and now 1 person in Canada. So if you're interested in using Clojure to fix airplanes or working remotely, please reach out. My email is dom@beacon.works. For anything else, dom@paren.com, or my handle on Twitter and Clojure and Slack and basically anywhere where handles work is domkm. That's all. Thank you very much.